This lesson is on adding and subtracting radical expressions. And one way I introduce radical expressions to students on adding and subtracting the math operations is on talking about what do they already know about like terms. And they have been introduced to like terms with polynomials, so that's how I introduce this radical lesson. And so we talked about, well, like terms for polynomials means that it has the exact same variable, the exact same exponent. So it's going to be, we could have 2x to the third, we could have negative x to the third, we could have, as long as it has that same variable and same exponent. So x squared, you could have 1/2 x squared, 2x squared, negative x squared. Same thing for x's, you could have 4x, 9x, just x, constants 4, 3, 0. And we talk about those are the ones that you can combine when you add or subtract. So when we combine the ones in number 1, we're looking at x squared. If we put this in standard form, the x's, the only thing we have is a positive 2x. Remember that sign is in front of the variable, so that negative does not go with 2x. It's the positive, but you don't see it when it's a positive. And then 4 plus 5 is 9. Negative 4 plus 5 is 1. Sorry. And then minus 2. So negative 4 plus 5 is 1, and then minus 2 is negative 1. And that's all that you can combine. Then you have negative x to the third in the next one, and 2x squared, and then you have a positive 1x when you combine negative 3x and 4x, and then 1 minus 6 is negative 5. On the next one, we talk about, well, what does like terms mean for radicals? Well, just like if you had x's, like terms for radicals means you have the exact same number underneath the radical. So square root of 2, that's the same thing as saying 1 square root of 2 plus 4 square root of 2 is going to be 5 square root of 2's. And then you have a negative 3 square root of 5 plus 1 square root of 5, and understood 1 in front of it would be 1 minus 3, if you combine those numbers in front, would be negative 2 square root of 5. And then you have the last one, square root of 3. There's nothing that has a square root of a 3 underneath the radical on any of the other ones, so it is a like term by itself. And on the last one, if you can evaluate the square root, go ahead and do that. Square root of 25 is 5. Minus 2 times square root of 36 is 6. It's being multiplied because it's next to the radical. And then plus 2 square root of 2, plus square root of 2. I was thinking about the 8 ahead of there. The square root of 8, you can simplify that to 2 times 4. 2 times 2, there's a pair of 2's, so that's going to be 2 square root of 2. So now, if we combine like terms, that's 5 minus 12, and then a 1 square root of 2 plus 2 square root of 2 is 3 square root of 2's, and 5 minus 12 combines to make negative 7 plus 3 square root of 2. But polynomials is a good way to bring up like terms and to talk about what like terms mean with radicals.